Hey everybody, welcome back to Mr. A's geometry course. Today we're covering several sections from Unit 5, which all have to do with identifying congruent triangles. Let's get into it. We're coming off a lesson where we learned about congruent polygons, which are figures where all the sides are congruent to each other and all the angles are congruent to each other. But today we're going to be learning that for triangles, we have these things called congruency theorems. Right? And these theorems are ways for us to prove that triangles are congruent without knowing all the sides and all the angles are congruent between the triangles. So we can think of these as shortcuts to proving that triangles are congruent. Here's an example of the maximum amount of information you can have on your congruent triangles. We see AB congruent to QP and so on for our corresponding sides. Angle B congruent to angle Q, and so on for our corresponding angles. That's all three sides congruent, all three angles congruent. We don't need to know all of this to know that triangles are congruent. There's little shortcuts where if we have just a little bit of information, it's enough to know that the triangles are congruent and equal in measure. There are 5 of these theorems, 5 of these shortcuts, and each of them requires just 3 pieces of information. These are the abbreviations for all of them, and notice the first 4 all have 3 letters involved. That last one only has 2 letters, but there are technically 3 pieces of information that we need. So again, this is where we're talking about shortcuts. I don't need to know 3 sides and 3 angles. I don't need 6 pieces of information. If I just have 3 things in the right positions in the right spots for our triangles, we can prove that they are congruent to each other. Our first shortcut is the side-side-side congruency theorem. So if all 3 sides from one triangle are congruent to all 3 sides of a second triangle, then those triangles must be congruent. So that means we don't need to know any information about the angles. If the sides are congruent, the angles must be congruent as well. So that means if we see triangles with these markings, it's enough to prove that they're congruent by side, 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 because we have 2 sides with 1 dash, we have a second pair of sides, we have a third pair of sides congruent to each other. They're congruent by side, side, side. Helpful little review here of writing congruency statements. Remember that when we write these statements, we need them to match in every way. All of our corresponding sides that are congruent need to be in matching positions in the statement. So I'm going to name this triangle however I want to. I'm going to call it triangle BCA. So just randomly naming this one, but I'm going to name the other triangle in a way where all corresponding things are in matching positions to BCA, right? For example, side BC has 1 dash on it. We know that needs to be congruent to this side, so those letters need to be in matching positions in our name here for our congruency statement. And the appropriate name I would have to call the other triangle would be YZX. Because we could then see like our last 2 letters, CA, would correspond with our last 2, ZX. Our first and last letters, BA, would correspond to YX. And we would say now that they are congruent to each other by the side-side-side congruency theorem. So the basics here is visual recognition of the side-side-side theorem. We're being asked, are these triangles congruent to each other? We don't have any information about the angles, but we do fit the criteria for side-side-side, right? This side is congruent to this side. That's 1 pair of sides. That's the S in our abbreviation. This side is congruent to this side, that's a second pair of sides, and this side is congruent to this side, that's third pair of sides. So we could say, yes, these triangles are congruent by the side-side-side theorem. In this example, we're being asked specifically if the side-side-side congruency theorem applies to these 2 triangles. In order to answer questions like this, we just need to evaluate the given information on our triangles. We know side FA is congruent to side LP, that is 1 pair of congruent sides. We know side AT is congruent to side LI, that is a second pair of congruent sides. But notice we lack dashes on our third sides. So we do not have evidence of the side-side-side theorem in these 2 triangles. So the answer to this would be no. We cannot prove these are congruent by the side-side-side theorem as is. Our next shortcut is the side-side-side theorem. If we have 2 sides and the included angle, which would be the angle in between those congruent sides, If those are all congruent to two sides in the included angle of a second triangle, then they would be congruent by side, angle, side. So again, this is a very visual concept that we're learning here with these congruency theorems. Let's make sure we understand the visuals. Here we have two triangles. We have a pair of sides here, it's a side. We have a pair of sides here, that is a side. And notice the angle between these congruent sides are marked congruent to each other, the same amount of arcs. That makes these congruent by the side, angle, side theorem. That's the criteria we need here. So again, I don't need this side, I don't need those angles. If I have this information on two different triangles, I could say they're congruent by the side, angle, side theorem. Again, I'm gonna name this triangle however I want to. I'm gonna call this triangle ABC. Now I can match that name with corresponding pieces from my other triangle. For example, I know angle A is congruent to angle D. Those need to be in matching positions. If angle A is the first letter, angle D needs to be the first letter here. Now I can look at sides. Side AB, my first two letters here is congruent to side DE. So D and E need to be my first two letters, which means F would have to be the last letter. So triangle ABC is congruent to triangle DEF by the side, angle, side theorem. Our next example is the most common problem we're going to have in this lesson. It's which theorem, if any, would prove that these triangles are congruent to each other. And again, this is a very visual thing, just evaluating the information that's being given to us on our triangles. We have side AB congruent to side DE, that's a pair of sides. We have side AC congruent to side DF, that is a pair of sides. And again, the key for the side angle to side theorem is that the included angle needs to be congruent. So the included angle of triangle ABC over here is angle A. That's where those two sides meet each other. And the included angle for that triangle is D. It's where those two marked sides meet each other. So the angles in between the congruent sides are congruent. That gives me that included angle. And so I have criteria for the side, angle, side theorem. And say yes, congruent by side, angle, side. So I guess yes or no, it wasn't involved in there. Just congruent by side, angle, side theorem. I love the error analysis type of questions, or the questions that ask us why something is not happening or occurring in an example. This is asking us why these triangles are not congruent by the side, angle, side theorem. Because at first glance, we do have two sides and an angle, two sides and an angle. However, the positioning of these angles is wrong for the side, angle, side theorem, right? We have two sides, but the angle that's congruent is not the included angle of those sides. The included angle for this triangle would be angle A. The included angle for the other triangle would be angle Z. Those angles would have to be marked congruent to each other for us to prove these triangles congruent by the side, angle, side theorem. So we would say that the included angles are not congruent to each other. That is why these are not congruent by the side, angle, side theorem. Our next theorem is the angle, side, angle theorem. It's very much like side, angle, side, just with two angles in the included side instead. So two angles and the side between. From one triangle, if those are congruent to two angles and the side between from another triangle, they would be congruent by the angle, side, angle theorem, right? So we have our two triangles here. We notice that there are two angles marked, a side mark and a side marked. And again, the key is that that side is included. It's between my two marked angles. That side is between my two marked angles. If that side was over here on EF and not there on GF, it would not fit the criteria for angle, side, angle, all right? From here, we can write a congruency statement. I'm gonna call this triangle ABC. Again, that's just a random selection for that name, but now I name this one in a way where all the congruent stuff corresponds in the statement, right? For example, I know angle C is congruent to angle G, so since C is my last letter, G must be my last letter over here. I know that angle B is congruent to angle F, so since B is the middle here, F needs to be the middle over here, and that means E would have to be my first letter. So triangle ABC is congruent to triangle EFG by the angle, side, angle theorem. Again, we have our most common example of the lesson here. It's just, are these triangles congruent? Do we have enough criteria to prove the triangles are congruent to each other. So we're evaluating. We have angle B congruent to angle E. That is an angle. We have angle C congruent to angle F. That's another pair of congruent angles. And then we have the side in between the congruent angles being marked congruent to each other. That's the included side. So we can say, yes, these triangles are congruent by the angle side angle theorem. In our next example, we have another one of these why not questions. Why are these not congruent by the angle side angle theorem? Because we do have two angles in the side, two angles in the side, but again here the positioning is off. The included side of angles A and B is side AB. That would be this side. The included side of angles K and L would be side KL, which would be this side. So because the included sides are not congruent, or not marked congruent, we do not have the angle side angle criteria. All right, so we could say included sides not congruent to each other. So why these are not congruent by the angle side angle theorem. Our next shortcut is the angle side theorem. So it's the same amount of criteria as angle side angle with three pieces, two angles, one side, but the positioning is different now. So if we have two angles and a non-included side of those two angles being congruent to two angles and a not included side from a different triangle, those triangles would have to be congruent to each other. So as it shows here, two congruent angles, the side marked congruent is not between those two angles. The side marked is not between those two angles. This still gives us congruency. We just call it the angle side congruency theorem instead of angle side angle, right? So for the triangle on the left, I'm going to call it triangle ABC. Again, just a random pick of a name. We're going to match all the corresponding things from our other triangle. Angle A is congruent to Y. A was first, so Y needs to be first. B is congruent to Z. B was second, so Z needs to be second. And then it leaves X for our last letter there. Triangle ABC is congruent to triangle YZX by the angle side theorem. Again, because the side is not the included side of the two angles. We're determining here if these triangles are congruent. I'm going to give you a different little way here of how you can answer questions like this, which requires you to memorize all of your theorems and to write them out in a short little list. Side, 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 angle, side, angle, and angle, side are the four that we've gone over so far. And we can just look at the given information and just do a little process of elimination on all of our theorems. For example, there's no way these triangles are congruent by side, side, side because I only have one side marked on each triangle. I need all three sides to be congruent for the side, side, side theorem to apply. So it cannot be the side, side, side theorem. For the same reason, these cannot be congruent by side, angle, side because that requires two S's, two sides to be congruent. Again, I only have one. So this leaves us with angle, side, angle, and angle, side as options. Okay, and then this is where we have to be really, really careful because as we look at this triangle, we have two angles and the included side, and that fits this theorem, angle, side, angle, the little green dot here, so the green arrow represents this triangle. However, this triangle, that congruent side is not the included side of these two angles. So that would give us this theorem, angle, side. And it is very important to note that we must have matching criteria to say that the triangles are congruent. So yes, angle, side, angle is a congruency theorem. Angle, side is a congruency theorem. But these are not the same congruency theorem. Therefore, we cannot conclude that these triangles are congruent to each other. And typically, the correct response for that would just be not enough information to prove that these triangles are congruent. In our next example, we can follow that same logic if we just list out all of our theorems that we know so far. Those are our four options, and we just test them on our figures. I have two angles, one side. Two angles, one side. No way it's side, side, side because I don't have three sides marked. No way it's side, angle, side because I don't have two sides marked, only one. So that leaves us with angle, side, angle, and angle, side. Notice on this triangle, the side that is marked is not the included side of these two angles, so that would give me this criteria. And this triangle also gives us a side that is not the included side of my two angles. That also fits this criteria. So, matching criteria here, we would say yes, these triangles are congruent by the angle side theorem. This brings us to our last congruency theorem, our last shortcut here, which is the most unique one. It's the hypotenuse leg congruency theorem. This is when the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle. So even though there's two letters there, it's still three pieces of criteria. We need a right triangle, we need the hypotenuses to be congruent, we need the legs to be congruent to each other. If you're unaware of the sides of the right triangle, there's a little visual here to help you. The hypotenuse is always the side that is across from the right angle. It's the only side that doesn't touch the right angle. Notice this leg CB touches angle B, the right angle. This leg AB touches B, the right angle. Side AC does not touch B. That's the hypotenuse. For this triangle over here, SR, that red side, would be the hypotenuse there. So we have right triangles. The hypotenuses are marked congruent. They both have one dash on them. And then one pair of the other sides, because both of these are legs. So we only need one other pair marked congruent, which we have there. That gives us congruent triangles by the hypotenuse leg theorem. I'm going to call this triangle on the left triangle BCA. I know angle B is congruent to angle T, so I need to make T the first letter for this name to be matching positions. I know that side BC is congruent to side TR, so since BC are my first two letters, TR needs to be my first two letters here, which means S will have to be the last letter. These are congruent by the hypotenuse leg theorem. Again, you need right triangles. You need that longest side that's across from the right angle to be congruent on your right triangles, and then you need one more pair of sides congruent to each other for the hypotenuse leg theorem. In this example, we're specifically being asked about the hypotenuse leg theorem. Can we prove that theorem with these figures? The first bit of criteria is here for us. We have right triangles. The problem a lot of students have, though, is when they see right triangles, they think automatically they have to be congruent by hypotenuse leg and that no other theorem would apply there. That's not the case here. These triangles are congruent by side angle side. Two sides, the included angles are both 90. Those are congruent angles. This gives us the side angle side theorem. The reason it's not hypotenuse leg is because the hypotenuses of these triangles are blank. AC is the hypotenuse here, FD is the hypotenuse there. Those are not marked congruent to each other, so we cannot prove them congruent by that theorem. We can prove them congruent to each other, though, by the side angle side theorem. So, no, not congruent by hypotenuse leg. They are congruent by side angle side. For this example, I'm going to give you that little process of elimination idea again. So we're going to write down all of our theorems. We know all 5 of them now. Side, 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 angle, 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 side, hypotenuse leg. And we're going to test all of those theorems to the criteria or that information that's given here on these triangles. So first, we can eliminate side, side, side because we don't have all 3 sides marked congruent on these triangles. So there's no way we can have the side, side, side theorem. We can also eliminate the side angle side theorem because even though we have 2 sides in an angle, the included angles are not congruent. For side angle side, we would have to have angle Z congruent to angle A. So because the positioning is off there, we do not have the side angle side theorem. We don't have angle side angle because we don't have 2 pairs of angles. We only have angle B, only 1 angle marked on each triangle. So angle side angle doesn't work. Angle side doesn't work for the same reason because again, I only have 1 angle. So that leaves hypotenuse leg as the only possibility. And because these are right triangles, we fit that first criteria that we need. From there, remember the hypotenuse is the side across from the right angle. Across from angle B is side AC, across from angle Y is side XZ. Those have 2 dashes, so our hypotenuses are congruent to each other. Then we just need 1 other pair of congruent sides, which we have. Side YZ is congruent to side AB. So we have right triangles, hypotenuses are congruent, legs are congruent. That makes these congruent to each other by hypotenuse-leg congruency theorem. One thing you may have noticed in all the examples that I've shown you here is that all these triangles that I've shown you are non-adjacent. They are not touching each other. They're separate from each other. The examples that we do have adjacent triangles that are connected in some way, those are going to be the ones that students tend to struggle with most, because oftentimes there's true information in there that's kind of hidden. It's not obvious to some people. For example, we will have adjacent triangles that share a side, like these two triangles both share side AB. We will also have triangles that meet at a vertex and create vertical angles. Remember, vertical angles are these angles that are across from each other. And in these scenarios, we are responsible for knowing that side AB is a congruent shared side for both triangles. We're responsible for knowing that those vertical angles are congruent to each other there at N. So when we look at this example, which at first glance is just two pairs of sides, we are responsible for marking the shared side DB for both triangles, okay? So that really is this, where this triangle has a side with 1, a side with 2, a side with 3. This triangle has a side with 1, a side with 2, a side with 3. These triangles are congruent by the side theorem, right? For vertical angles, right? We see these angles are vertical to each other. We are responsible for knowing that they're congruent. So when we see an example like this, this is actually happening. Our vertical angles are congruent, and therefore these triangles would be congruent by the side angle side theorem. And we'll see a few more examples now of how we can apply the shared side and vertical angle idea for our more complex examples of congruent triangles. We're adding this layer now where we are responsible for marking any shared sides or vertical angles on our triangles that are adjacent, like they are in this example. We're going to continue this trend of like a process of elimination after we first mark what we're responsible for. Both of these triangles share side PX. We are responsible for marking them congruent to each other. It's important to note that some places that you may look at will mark them like this, those shared sides. I like just putting dashes on them like we would for any other congruent sides. So as we add that mark, we can then go down our list of theorems to see if any of them apply. These cannot be congruent by side because we don't have the third sides congruent to each other. They are not congruent by side angle side because the included angle for our sides would be up here at P. And those are not marked congruent to each other. Can't be angle side angle because we only have one pair of congruent angles. For the same reason, it cannot be angle side. We do have triangles that are congruent here by hypotenuse leg because they are both right triangles. The hypotenuses are marked congruent to each other and they have a pair of congruent legs, congruent by hypotenuse leg. In our next example, we have another set of triangles that are sharing a side. They share this side in the middle. So again, we mark what we're responsible for when our triangles are adjacent, and then we test all of our theorems on them. These cannot be congruent by side because our third sides are not marked congruent. Right, we are going to skip side angle side for a moment because that is what they are congruent by. Not congruent by angle side angle because we don't have two pairs of congruent angles. Same reason, they cannot be congruent by angle side. These are not congruent by hypotenuse leg because even though these are right triangles, the hypotenuses are not marked congruent to each other. That leaves only the side angle side theorem as a possibility, and that does work because these right angles are the included angles of our congruent sides. That's in between these two sides for that triangle, right angle in between these for that triangle. These are congruent by the side angle side theorem. Right? In our next example, we have vertical angles that we are responsible for marking. Right there at point C, we have vertical angles. We're responsible for marking that and testing our theorems. We don't have enough sides for side or side angle side. We don't have right triangles, so it can't be a hypotenuse leg. We do have two angles and a side for each triangle. The sides marked are my included sides for these angles. So that's one with the side in between, this one and not angle side. These are congruent by the angle side theorem. All right, last one here. We have, again, vertical angles that we are responsible for marking. Right here at C, have to be congruent to each other. There's nothing else that we can add to this. Only vertical angles or shared sides are going to be marked here at this stage. These are not congruent by side, side, side. Don't have enough sides. Don't have enough sides for side, angle, side. I don't have enough angles for angle, side, angle. I don't have enough angles for angle, angle, side. I don't have right triangles for hypotenuse, leg. Therefore, there is not enough information. Not enough info to prove that these triangles are congruent. We're going to look at some unique special cases now for congruent triangles like this one. These triangles are adjacent to each other. However, they are not sharing a side. It is very important to note those angles there at H are not vertical angles because we need straight segments intersecting each other, which is not happening here. Yes, we have a straight segment from G to K, but when we go from F to H, we're changing directions to get to J. We're not continuing straight to get vertical angles here. So we cannot mark anything extra congruent in this example. Therefore, we can only take those side markings here into account. There's not enough sides for side, side, side. We don't have any angles, so it can't be any of those. These are not right triangles. There is not enough information to prove that these triangles are congruent to each other, right? Very specific case here. I hope you can see on screen that side PQ and side TS both have one arrow on them. That makes them parallel to each other. So in an example like this, not only are we going to get vertical angles here at R that we're responsible for marking, we are also going to get alternate interior angles that are going to be congruent to each other. Our parallel lines are giving me alternate interior angles here and here. They're also giving me alternate interior angles here and here. And so that really gives us a choice of theorems. If I look at QR in this side and look at RT in this side, they would be congruent by angle, side, angle. If I look at any other two angles that are involved here, it would give me congruence by angle, angle, side. So angle, side, angle, or angle, angle, side would prove these triangles are congruent to each other. All right, we'll keep that in mind as we look at an example like this. Again, we're responsible for marking our vertical angles congruent. We have alternate interior angles N and L. We have alternate interior angles P and M. We have no sides though. This is important to understand. It can't be any of these. We don't have any sides congruent. They're not right triangles, so they're not congruent by hypotenuse, leg. Very important to understand that angle, angle, angle is not a congruency theorem, right? There is not enough information to prove that those triangles are congruent to each other, right? We do have enough information in this example though, because we have shared side that we are responsible for marking in L. It's congruent between both triangles. And then all of my parallel sides are giving me alternate interior angles. So KLN, that angle, would be congruent to MNL, alternate interior angles there. And then KNL, this angle would be congruent to this one, NLM, right? And that will give me congruent triangles by the angle side angle theorem, okay? Not enough sides, don't have right triangles. Then we have the included side. So we have angle side angle congruency here for these triangles. Last thing we have to cover here in this lesson is proving triangles are congruent by adding a piece of information that is not currently given. So this example is asking us to make these triangles congruent by the side angle side theorem. The first thing I'd like you to do for something like this is account for the congruent parts that we already have. For example, LT is congruent to MQ. That is an S. That is a pair of congruent sides. Angle L is congruent to angle M. That is an A. That's a pair of congruent angles. Because we need the side angle side theorem, what's missing is a second pair of sides. And remember, for this theorem, we need the angle to be included. It needs to be in between the sides. So if we look at this triangle, the side to mark that would sandwich the angle in between would be this side. And for this triangle, the side to mark would be MN. Therefore, the missing piece of information would be segment LS needs to be congruent to segment MN. Okay? In our next example, we need the missing piece of information for the hypotenuse leg theorem. Okay, for this, it's important to note these are adjacent triangles. Remember, we are responsible for marking that shared side. That is not missing information. That is expected to be known. What's missing for us in this one is these triangles being right triangles. We need to say that in a very specific way. We could say, okay, angle ADB and angle CDB need to be right angles. But what we can do to make that more specific, what we can do to give us a better explanation there is to say that AC is perpendicular to BD. Because perpendicular things will intersect and give us right angles. That would be the missing thing here to give us hypotenuse-like congruency. Okay. Next, we need the missing piece for the angle side angle theorem. These angles are not touching. There's nothing that we can add to this, so we're just accounting for what we have. We have angle B congruent to angle E. That's a pair of congruent angles. That's an A. We have side DE congruent to side BC. That's an S. So the thing that's missing, we have an A and an S. We're missing another pair of congruent angles. For angle side angle, we need that side to be included. It needs to be in between our angle marks. So for this triangle, that would have to be here at C. For the other triangle, that would have to be at D. So what's missing for angle side angle is angle C needs to be congruent to angle D to give us angle side angle congruency. On this one, we need angle, this was a mistake here, this should be angle side congruency here. Okay, we need to find again the missing piece of information. We know E is congruent to B, that gives us one angle. We know side BC is congruent to side DE, that gives us one side. What's missing is an angle that is not putting the side between, that is not making this the included side. So that would have to be angle A for this triangle over here and angle F for this one. Angle A being congruent to angle F would give me angle side congruency here for these triangles. Guys, that wraps up our lesson here on congruent triangles. We'll see you in the next one.